Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0171, indicates that the rear bank fuel system of the Honda Accord from 2008 to 2012 is too lean, which means the engine is receiving insufficient fuel compared to air. This can lead to a range of engine performance issues, including rough idle, poor acceleration, and increased emissions. The MAF, in the error name, refers to the mass airflow sensor, responsible for measuring the amount of air entering the engine for the optimal fuel-to-air ratio. Proper functioning of the MAF sensor is crucial as it directly impacts the fuel delivery system. The rear bank in V6 engines relates to bank 1, which typically includes the cylinders on the driver's side. Ensuring accurate diagnosis and timely repairs is essential to maintain engine performance and compliance with emission standards. The error code P0171 specifically affects the rear bank, which is also referred to as Bank 1 in the Honda Accord V6 configurations. The fuel mixture in this bank is indicated to be too lean, which signifies that there is more air than fuel in the combustion process. This imbalance can lead to engine performance problems and increased emissions. The mass airflow, MAF, sensor plays a vital role here by measuring the volume and density of the air entering the engine. The MAF sensor is located in the intake air duct, downstream from the air filter. Its accurate functioning is crucial for the engine control unit, ECU, to adjust the fuel injectors and maintain an optimal fuel-to-air ratio, which is essential for efficient combustion and overall vehicle performance. Several possible causes contribute to the P0171 error code. A malfunctioning mass airflow (MAF) sensor may give incorrect readings, leading to an improper fuel mixture. Additionally, vacuum leaks within the intake system can allow excess air into the engine, compromising the air-to-fuel ratio. Issues related to fuel delivery, such as a failing fuel pump or clogged fuel filter, could also result in insufficient fuel reaching the engine. Another possibility is the presence of disconnected components in the air intake and fuel systems, which may arise from wear or improper maintenance. Troubleshooting these areas methodically is essential to identify and rectify the source of the lean condition. The symptoms associated with DTC P0171 can vary, but some common indicators include a rough engine idle, particularly when the car is at a standstill. Drivers may also notice poor acceleration, where the engine hesitates or struggles during acceleration. An increase in fuel consumption may occur as the engine management system attempts to compensate for the lean condition, further stressing the fuel system. The check engine system. Light will typically illuminate on the dashboard, alerting the driver about the malfunction. Recognizing these symptoms early on can prompt timely diagnostics and repairs, thereby preventing further engine damage and ensuring the vehicle operates efficiently. In the first troubleshooting step for diagnosing the P0171 code, start the vehicle's engine and let it idle without any load, ensuring automatic transmissions are in P or N and manual transmissions are in neutral. During this time, utilize the Honda Diagnostics System, HDS, to monitor the short-term fuel trim values for both banks, referred to as ST Fuel Trim B1 and ST Fuel Trim B2. If either of these values reads 1.15 or greater at idle, this indicates that the fuel trim is too high, thus confirming the presence of a lean condition. In this scenario, proceed to Step 3 for further investigation. However, if the values are normal, move on to Step 2 for additional diagnostics. For the second step in diagnosing the P0171 issue, it's essential to review the onboard snapshot data when the short-term fuel trim was at its peak. This involves documenting various parameters such as engine speed, vehicle speed sensor, VSS readings, throttle position sensor, TP sensor, coolant level, CLV, and accelerator pedal position, APP sensor. After recording these parameters, take the vehicle for a drive under conditions matching those observed during the highest fuel trim readings. Monitoring for instances where either ST fuel trim B1 or B2 hits or exceeds the 1.15 mark during this snapshot review is crucial. If confirmed, move to step 3 for further troubleshooting. Otherwise, your system may be operating normally. In the third step, checking the mass airflow sensor for any debris is critical. Begin by carefully removing the mass airflow sensor from its housing. It is important to inspect the sensor for any lint, bugs, or foreign objects that might obstruct its functionality. Debris in the mass sensor can lead to skewed readings, which directly impacts the fuel delivery system and causes a lean condition. If debris is found, proceed to clean the sensor thoroughly and use a vacuum cleaner to remove any additional debris from the air cleaner housing to prevent future occurrences. Once cleaned, reinstall the mass airflow sensor and proceed to step 4 for further investigation. The fourth troubleshooting step involves a thorough visual inspection to identify any disconnected or damaged components in the intake and vacuum systems. Prioritize the crankcase breather hose, intake air duct, oil cap and dipstick, and the air cleaner housing. Ensure there are no cracks, loose hoses, or visible wear and tear that could lead to vacuum leaks. Any compromised components can alter the air intake, contributing to an overly lean fuel mixture. If damage or disconnections are discovered, repair or replace these components as necessary. If everything appears intact, then proceed to step 5 for the next phase of inspections. In the fifth troubleshooting step, check the vacuum engine mounts while the engine is idling. Upon starting the engine, let it idle and use the HDS to set up a high-speed snapshot for air-fuel feedback, AFFB, specifically monitoring the short-term fuel trim. Then, pinch the engine mount vacuum hose that connects to the intake manifold. This action will help determine if any uncontrolled vacuum leaks are present in the engine mount system. If the ST fuel trim remains at or above 1.15 after pinching the hose, it indicates that the vacuum-controlled engine mount is functioning correctly. If the condition worsens, investigate the vacuum hoses and engine mount control solenoid for potential leaks. And if no leaks are found, consider replacing the front vacuum-controlled engine mount. Continuing with troubleshooting, the sixth step involves inspecting the brake booster vacuum hose while allowing the engine to idle. Maintain engine idle and pinch the vacuum hose leading from the brake booster to the intake manifold. This process is aimed at determining whether vacuum leaks within the brake booster system are contributing to the lean condition. Keep an eye on the ST fuel trim values for either bank as you monitor this condition. If it remains at or above 1.15, this indicates that the brake booster is functioning correctly without leaks. Conversely, if the fuel trim value drops below this threshold, then there may be leakage in the brake booster or its associated hoses, necessitating further inspection and possibly replacement. The seventh diagnostic step requires checking the positive crankcase ventilation (PCV) system to identify any possible vacuum leaks. Like previous steps, while continuing to idle the engine, pinch the vacuum hose that connects the PCV system to the intake manifold. Monitor the short-term fuel trim values during this process to see if they remain steady. If ST fuel trim B1 or B2 remains at or above 1.15, it signifies that the PCV system is intact without leaks. If there's a decrease in this value, it indicates a leak in the PCV system that necessitates further inspection of vacuum hoses for any signs of wear or damage, followed by necessary repairs to ensure proper function. Continue with troubleshooting by focusing on the evap canister purge system, ensuring the engine continues to idle. Pinch the vacuum hose leading from the evap canister purge valve to the throttle body. This step will allow testing for any potential leaks that might be present in the system. Monitor the ST fuel trim B1 or B2 values during this observation. If these values remain at 1.15 or higher, it indicates that the evap canister purge valve and associated hoses are not leaking, which is ideal for maintaining proper engine operation. If the values drop, it suggests a leak in the evap canister area, warranting additional inspections and subsequent repairs to keep the fuel system functioning optimally. For the 9th step, start the engine and bring it to a steady idle of 3,000 RPM until the radiator fan activates. This elevated RPM is important for capturing precise readings from the MAF sensor under load. Ensure that the engine coolant temperature, ECT sensor 1, is above 158 degrees Fahrenheit, 70 degrees Celsius, that the automatic transmission is in park or neutral, and that all electrical loads in the vehicle are turned off. While maintaining this engine speed, monitor the MAF sensor reading via the Honda Diagnostic System. The MAF specifications for a 2008 to 2011 Accord V6 should fall between 9.1 to 12.9 grams per second at 2,500 RPM. If the MAF is within this range, it indicates functionality. If it deviates, inspect the air cleaner assembly for damage or misalignment. And if no issues are found, consider replacing the MAF IAT sensor. The 10th step involves checking the fuel pressure to identify any inadequacies contributing to the P0171 code. Assess the fuel pressure when the ST fuel trim B1 or B2 values are both above 1.15. as this will give the most relevant indication of the fuel system's performance. For the 2008 to 2011 Accord V6, the acceptable fuel pressure should fall between 57 to 64 psi. If the pressure is found within these specifications, the fuel supply system is functioning correctly, and you can proceed to the next steps. However, if the fuel pressure is below this range, it is indicative of a problem that may require replacing the fuel tank unit, ensuring the vehicle receives a sufficient fuel supply. In the 11th troubleshooting step, the goal is to check for any vacuum leaks in the intake manifold that could affect the overall fuel mixture. Start by disconnecting the intake air duct from the air cleaner housing for access. Then connect an OTC LeakMaster smoke machine, which generates smoke to help visualize any leakage. Direct the smoke into the intake manifold and thoroughly inspect points like the intake manifold and gaskets, throttle body, EGR valve gasket, and any vacuum or air hoses for escaping smoke. Identifying leaks at these junctures is crucial, as even small leaks can lead to considerable issues. If any leaks are found, repair them accordingly before proceeding to the next step. In this 12th step, replace the fuel injectors with a set of known good injectors. Fuel injectors are critical in delivering the precise amount of fuel required for combustion, and if they are malfunctioning, they can lead to lean fuel conditions evidenced by high short-term fuel trim values. After replacing the injectors, operate the vehicle under conditions similar to when the ST fuel trim B1 or B2 was previously found to be high. Monitor the ST fuel trim values closely. If they remain elevated at or above 1.15, the malfunction may lie elsewhere in the system. If the values normalize, the original injectors were likely to blame for the issues faced. For step 13, the air fuel sensor should be replaced if all previous diagnostics have ruled out other causes, but high fuel trim values persist. The air-fuel sensor is responsible for measuring the oxygen content in the exhaust gases and is crucial for maintaining an accurate air-fuel mixture in the engine. After replacing the sensor, it is important to operate the vehicle under the same conditions where the STEP fuel trim B1 or B2 levels were elevated. Monitor to see if the values remain at or above 1.15 post-replacement. If they do, then the air-fuel sensor was not the underlying issue, and further investigation into other possible faults is needed. The 14th step emphasizes the possibility of a fuel-related issue, particularly if the P0171 code appeared shortly after refueling. In this situation, it's advised to remove the fuel tank unit and drain it thoroughly before refilling with known good fuel. This step eliminates any doubts regarding the quality of the fuel being used. After replacing the fuel, operate the vehicle under the conditions previously defined, where ST fuel trim B1 or B2 showed high values. If the levels remain elevated following this adjustment, it may indicate that the problem is not with the fuel itself, prompting a substitution of a known good engine control module, ECM/PCM, to further isolate the issue. The final step in troubleshooting the P0171 code entails confirming repairs made by resetting the engine control module, ECM, or powertrain control module, PCM. Engage the ignition switch to the on position and utilize the HDS to perform this reset. Following this procedure, it's crucial to conduct an idle learn procedure, which allows the system to recalibrate its settings after repairs. After this procedure, start the engine and hold the engine speed at 3,000 RPM without any load until the radiator fan engages. Once completed, let the engine idle again and recheck the ST fuel trim values. If they remain elevated at or above 1.15, further diagnostics may need to occur starting back at early troubleshooting steps, while a return to normal levels indicates that the repair process was successful. After completing all troubleshooting and potential repairs for DTC P0171, it is essential to conduct a final repair verification process. This involves monitoring the vehicle for any resurgence of the DTC, as intermittent issues can reappear if not correctly addressed. Verify the stability of the ST fuel trim readings during various operating conditions to ensure that the fuel system operates efficiently and effectively. Additionally, observe the overall engine performance, making sure that it runs smoothly under normal driving conditions without any signs of hesitation, poor fueling, or abnormal noises. This comprehensive approach ensures that the vehicle can return to reliable operation and confirms that the underlying issue has been addressed. Conducting preventive maintenance is key to avoiding future occurrences of DTC P0171 and ensuring optimal engine performance. Regularly check the MAF sensor for cleanliness and proper installation, as this sensor's condition significantly influences the engine's fuel management system. Moreover, schedule routine inspections of vacuum hoses to catch any signs of wear or damage early on. Replacement of these components can reduce the chance of leaks. Additionally, using high-quality fuel can prevent many fuel-related issues that could lead to lean conditions. Establishing a comprehensive maintenance routine will extend the life of your engine and maintain performance standards. To conclude, DTC P0171 signifies a lean condition in the rear bank of the Honda Accord's fuel system, primarily associated with the MAF sensor. Accurate diagnosis and immediate identification of potential issues associated with fuel delivery and air intake are vital for restoring proper engine functionality. Each troubleshooting step, from monitoring fuel trim values to inspecting physical components, plays a crucial role in pinpointing the source of the problem. By emphasizing preventive maintenance, such as regularly checking the MAF sensor and vacuum systems. Vehicle owners can mitigate the chances of recurrence of such fault codes. Overall, early detection and proactive measures can significantly enhance the performance and longevity of your vehicle. Please like and subscribe to the channel. See you next time.